All right, geometry students, this is lesson 8-1. It's titled Quadrilaterals, and it begins on page 310 in print, and in Braille, A310. And the first line reads, "The building below was designed by Lorinda Spear." So find 310 and 310A in Braille. What this has on it is a tactile of a picture that's in the book of this building that was designed by Lorinda Spear. And it shows that different quadrilaterals were used as faces of the building, and they outline in particular the face of this building, and it has a four-sided heavy dotted outline on the right-hand side of your tactile. And the information on the left-hand side is just kind of the solar panels and another part of the building. But they want you to focus on the heavy dotted line to the right. There's four of them coming together to create this irregular quadrilateral, this four-sided figure. And in the picture in print, it's outlined in yellow. And so just giving you kind of a little real-life graphic of a quadrilateral. And then down below, or actually it talks about down below the drawing that the Center for Innovative Technology is in Fairfax in London counties, Virginia. So if you turn the page to the Braille page to 310B, we're right in the middle of the print page, it has a little paragraph of information about what the definition of a quadrilateral is. So it says a quadrilateral is a closed geometric figure with four sides and four vertices. The segments of the quadrilateral intersect only at their end points. Special types of quadrilaterals include squares and rectangles. We'll learn about those different types of quadrilaterals in later sections, but now we're just going to focus on the definition: four sides, four vertices, where the end points form those vertices. So there are four pictures on this Braille page that are quadrilaterals, and then we'll go over those, and then when we turn the page there'll be four pictures that are not quadrilaterals. In print, they have a green box with, on the left, they have examples of quadrilaterals that meet the definition, and on the right, they have examples that aren't quadrilaterals. So here are four quadrilaterals. There's one on the top left. Notice it has four sides. Make your way around that drawing there. This is actually looks like a trapezoid. It doesn't quite have the indicators on it that make it for sure look like a trapezoid, but it's getting close. You have a top sides that are parallel or look like they're parallel to each other, and then top and bottom side, and they're called the bases in a trapezoid, and then you have your sides that, if they extended, would end up crossing each other. But notice there's four vertexes where the end points come together of each side, and four sides. So this is a quadrilateral. Move immediately to the right. There's another example of a four-sided figure. Make your way around that figure. Count those sides. You have 1, 2, 3, 4 sides. It's an irregular quadrilateral again. It doesn't have a special name. There's four vertices where the end points of each side come together, so it matches the definition. Go to the drawing on the bottom left, and this looks interesting. Sometimes people, when they look at this drawing or feel this drawing, they say, oh, it's a triangle. But be very careful. You have your left side and your right side, and then notice from the right it pitches in from about 4 o'clock to 10 o'clock, and then it makes a slight bend and goes from, imagine, 2 o'clock to 8 o'clock. Those are two separate sides because of that bend, and it's created four vertexes. At the endpoints there at the bottom of the figure in the middle, these two endpoints come together and it creates an interesting vertex where it has what's called concave angle. It's an angle that's pushed itself into the figure. So it still is technically a quadrilateral because it has 4 vertexes. Vertexes don't have to be less than 180 degrees. This one is well over 180 degrees. And then there's a drawing at the bottom right that looks like it might be a parallelogram. It could even be a rhombus. A rhombus is a parallelogram with 4 equal sides. We don't have any tick marks to tell us. They're not really focusing on that in this section. They just want you to notice that it has 4 sides and 4 vertexes. If you turn the Braille page to 310C, you have 4 more figures that are not quadrilaterals. Immediately to the right in print, we have these same 4 figures. The top left, we've been working with this figure for several chapters. It's a triangle. So of course it's not a quadrilateral. It has 3 sides. It doesn't have 4. The one immediately to the right, well, some people could argue it looks like 2 triangles coming together at a point, but the top left vertex, if it was at 10 o'clock and then you followed it all the way down to 4 o'clock, that could technically be called a side. And then you go up from that bottom right position to the top right position. There's a side. And then the top right position from 2 o'clock, go all the way down and through that intersection point and down to the bottom left to your 8 o'clock position. That you could say, okay, there's a side. And then go back up to the left. So, well, okay, 1, 2, 3, 4 line segments, 4 sides maybe, but how many vertexes? Oh, wait a second. 1, 2, 3, 4, 5, 6. Not happening. This is not a quadrilateral. You could say it's 2 triangles that are a reflection of each other, possibly, or a rotation. The bottom figure in the left, bottom left, this should be, it's smaller, but if you really be careful going around it, you notice that it has several sides. It has, we start at the top and go from the top left to right, go clockwise. You have 1 and then a little teeny one, 2 going down, and then 3 going back across to the right, a little small one again, and then 4 going immediately down. Then you're going to go to the left just a little teeny bit, 5, and then down a little teeny bit, 6, then immediately to the left a longer one, 7, and back up just a smidge, 8, then over to the left again, 9, and then back up 10, over to the right 11, and then back up 12. There's 12 sides on this, so it's not a quadrilateral. And there's a whole bunch of vertexes. Go immediately to the right, and there's another figure. It has 1 side going top left to bottom left, and then at the top it has a side, and then all of a sudden the side starts to turn. And it's a curve, and it comes around to the bottom, and then it has a side. So this is to show you that curves are not considered sides. So this kind of has 3 sides and a curve. This is not a quadrilateral because it doesn't have 4 sides. It also does not have 4 vertexes. It only has 2. So those are examples of not being quadrilaterals. You turn the page, talks about how you name quadrilaterals. This is on 310D and at the very bottom of the print page, 310. It says quadrilaterals are named by listing their vertices in order. There are many names for a quadrilateral at the right, and you have the drawing down at the bottom, Braillers. Some examples are quadrilateral ABCD, or quadrilateral BCDA, or quadrilateral DCBA. We can name them frontwards or backwards. They don't have to be in alphabetical order, but what you have to do is wherever you start, you go in order, either clockwise or counterclockwise to the next vertex, and then the next vertex, and the next vertex, and that's how you name it. You don't jump around. So if we start in the top left at vertex A and go to the top right, we have that AB side, and then we go bottom right to C, B to C, and then bottom left to D, and then back up to A again. So we could name it, starting at A, we could name it A, B, C, D, if we named it clockwise, or we could name it counterclockwise, A, D, C, B. We could start at vertex B and do the same thing, name it clockwise and counterclockwise. So it could be quadrilateral B, C, D, A, or quadrilateral clockwise, counterclockwise, B, A, D, C. You can do that at each vertex, and that's how you can name a quadrilateral. Just know that you name the vertexes in order. And that's helpful if you don't have a drawing and you're trying to decide what angles are consecutive, what angles are opposite each other. Which that brings us to talking about consecutive and non-consecutive definitions of sides and vertexes. Now on the next page, 311, it talks about reading geometry at first. It says, reading geometry in a quadrilateral, non-consecutive sides, vertexes, or angles are also called opposite sides, vertexes, or angles. And we've used that working with our triangles, working with our parallel lines and transversals. We use opposite sides. And so then it goes on to say any two sides, vertexes, or angles of a quadrilateral are either consecutive or non-consecutive. And so what does that look like in a model, in a picture? So if you turn the Braille page to 311A, there's a quadrilateral, and then it has little arrows pointing at things, and then a key up above as to what they're pointing at. So let's just go make our way around the quadrilateral, ignoring those arrows. So start at the top left vertex P, and go to the top right vertex Q, and then the bottom right vertex R, and then back to the bottom left vertex S, and then back up to P. So there's the outline of this quadrilateral. It's just an irregular quadrilateral, and it's pointing at two things. On the left-hand side, it's pointing at, with an arrowhead, side PS, and then an arrowhead pointing down at side SR. And if you go up and read your key, and in the graphic and print, it says side PS and SR are consecutive. And that's because if you started at P and you were to imagine walking along P to S, and then you would turn the corner and go S to R, those are consecutive, right? You're using that same S vertex, PS and then SR. So if you start at P and went to Q, so P to Q, top right, then you turn the corner and go down to R. PQ is consecutive to QR. All right? You could start at R, down on the bottom right, go all the way over to the left to S. RS is consecutive to SP, because you turn the corner to go SP. So just one after the other, one side after the other. So then the next piece of information, they have arrows pointing off to the right. They have long arrows pointing into PS, and then an arrow pointing at RQ. There's a little key to that, number 2. And if you go up and read number 2, it says side PS and QR are non-consecutive sides. We have to jump across our quadrilateral to get to the other side. So they're non-consecutive. We also call these opposite sides. That's a more familiar term, is to say PS is the opposite side of QR or RQ. So you have to learn to identify your consecutive sides and your opposite sides from drawings and from just labeling. That's why it's important to know it's in order, like PQRS. If we started at P and went clockwise, quadrilateral PQRS, you could say, well, PQ, QR are consecutive. You just keep those letters in order. QR, RS is consecutive. You keep the letters in order. RS, and then S back to P, you just loop around, would be consecutive. The next drawing shows consecutive angles and then the diagonal that's created by joining them, non-consecutive, consecutive vertices and non-consecutive vertices. So you have a similar quadrilateral. They didn't label it in Braille, the vertexes, but it's still P, Q, R, and S, starting top left, and then top right is Q, and bottom right is R, and bottom left is S. So P, Q, R, S. And the top left to the bottom right vertexes, those are non-consecutive vertexes. They're opposite each other. And then they're showing also the top right Q to the bottom left S. Those are two non-consecutive angles. They're opposite each other. And then they draw a line in between the Q and the S, and they point to that with an arrowhead, and they have a key up above, and they let you know that that is a diagonal. And you could have another diagonal from P to R. So you can join opposite vertexes and make diagonals, non-consecutive vertices. Now the consecutive vertices would be S to P or S to R. Those would be consecutive, just one after the other, or P to Q or Q to R. But opposites would be PR, non-consecutive. You have to jump from the top left to the bottom right, and QS, top right to bottom left. Those are opposites or non-consecutive vertices. So turn the Braille page to 311C, and we do some practice with an example. There's kind of a diamond shape in the middle. This is a parallelogram or a rhombus. We'll learn about that later. All they're doing is just saying refer to quadrilateral ABLE. A is the far left, B is at the very top, and L is at the far right, and E is at the bottom. So ABLE. And it says name all the pairs of consecutive angles. So we could go, all right, if we start at A, because they're saying quadrilateral ABLE, so let's start where they want to start. The consecutive angle to A would be B. The consecutive angle to B would be L. So we'd have AB, then BL. The consecutive angle to L would be E, LE. And then the consecutive angle to E would be back to A again, A. Okay. If we want to name our quadrilateral in a different way, our consecutive angles would just follow that name. It also asks to name all pairs of non-consecutive vertices. So go back to A over at the right, or excuse me, the left, and jump across, go rogue across your quadrilateral to L. A and L are non-consecutive vertices. They're opposite angles. We could put a line in between those two and create a diagonal. Go find B at the very top and jump across, down, down, down across your quadrilateral to E. You get to its non-consecutive vertices. So BE are opposites. We could connect B and E together and create a diagonal. And that's the next question, is name the diagonals. So we have diagonal AL, or we could say LA, and we have diagonal BE or EB. How many diagonals are in this quadrilateral? 2, right? And the last one we just did, you notice there was 2. So I remind you to kind of remember to keep your inductive and deductive reasoning hats on when you go through geometry and be looking for interesting things that occur and kind of going, got a 4-sided figure with 2 diagonals. That's interesting. Each and every time so far. Turn the Braille page to 311D. We're at the very bottom of page 311. We have a big, huge rectangle in the middle of our Braille page. It's off to the bottom right in print. This quadrilateral, they're not naming it a rectangle, they're just saying quadrilateral, and that's good because there's no tick marks or right angle indicators, but it kind of looks familiar and looks like could be a rectangle. It says refer to quadrilateral W, X, Y, and Z. So W is your top left vertex, X is your top right vertex, Y is your bottom right vertex, and Z is your bottom left vertex. It says name all pairs of consecutive sides. So we'd start at W and start naming your pairs of consecutive sides. There's many of them. I want to pause and try to do it and then see what you end up with. So if we start at W, we would have W to X, and we turn the corner and we'd have X to Y. So WX, XY is a consecutive pair of sides. If we start at X, top right, we would go X to Y, then Y to Z. Those are two consecutive sides. And if we start at Z, we would go back up to W and turn the corner, turn right to X. So ZW is a consecutive with WX. That's naming them in order by how they labeled the triangle. They said, or not triangle, quadrilateral, WXYZ. You could start at any vertex and start walking your way around it clockwise or counterclockwise and name the consecutive sides in different order. Then letter B, down in the your turn underneath the drawing, says name all pairs of non-consecutive angles. So start at W. What is the non-consecutive angle to W? So go rogue through your triangle, go all the way across and find Y, WY. And then go up to X in the top right corner, and where is your non-consecutive angle to X? It's in the bottom left corner, opposite it, right? That is angle Z. So W to Y are opposites, X to Z are opposite. And then if we have to name the diagonals in little letter C, we connect our opposite vertexes, our opposite angles, W to Y, WY would be a diagonal, and X to Z would be a diagonal. And how many diagonals do we have in this quadrilateral? 2. That's interesting. We still get 2 with a 4-sided figure. All right, next page talks about looking back and the angle sum theorem. If we remember our angle sum theorem from chapter 5, that stated that triangles, something about triangles and their angles, and if we add them together, do you recall that? So if you add all the interior angles of a triangle, the sum is 180 degrees. So let's put that in our brain and remember that. Let's not flush that. Let's keep that. That's super important. Let's read on. It says, in chapter 5, you learned that the sum of the measures of the angles of a triangle is 180. You can use this result to find the sum of the measures of the angles of a quadrilateral. So if you turn the page, there's a drawing of a quadrilateral at the very top of 312. It's at the top right of 312 in print. We have vertex A at the top left. Follow that almost immediately to the right to top right to vertex B. Then down to the bottom right of vertex C. And then back over to bottom left vertex D. Back up to top vertex A. And then from vertex A to the angle opposite vertex A, which would be angle C, there's a diagonal that's drawn. What is this created by drawing that diagonal through our quadrilateral? Split up our quadrilateral into 2 triangles. They've labeled the interior angles of each triangle. We have a triangle on the left, ADC. They've labeled the angle up at A, angle 2. The angle at vertex D, angle 1, and one of the angles down at vertex C, angle 3. And then the triangle to the right, our ABC triangle, at A, the other side of the angle is 5, at B is 4, and at C is 6. Now, triangle ADC to the left has 3 interior angles. We don't know what those measures are, but do we know what 1, 2, and 3 have to add up to? We should be yelling out 180. So we got 1/2 of our quadrilateral is 180, and it's a triangle. Then we go to the other half, ABC, it's a triangle. It's got 3 interior angles. What do 4, 5, and 6 add up to? Hopefully you're yelling out 180. So if we have 180 for one side, 180 for the other side, if we combine those measurements, what are we going to get? And now you're yelling out 360. Yes. You put a diagonal through the quadrilateral, you create two triangles. Every quadrilateral is just two triangles. And so the sum of the measures of the interior angles are 180. So if we've got two of them, the sum of the measures of the interior angles of a quadrilateral are going to be 360. So by just kind of looking at this drawing and thinking about it, using some reasoning skills, we've deduced something. We've come up with a conjecture or the next theorem. And that is on the next page. Oh, excuse me, two more pages. Two more Braille pages in the middle of your print page 312. We're on 312C. It's Theorem 8-1. In words, the sum of the measures of the angles of a quadrilateral is 360. And then they give a model to represent a quadrilateral. It's just a four-sided figure, four vertexes. They've labeled the interior of the vertexes A degrees at the top left, B degrees at the top right, C degrees at the bottom right, and D degrees at the bottom left. And then down below the drawing in symbols, they represent the theorem that A plus B plus C plus D has to equal 360. Always, always, always. So we have an angle sum theorem for quadrilaterals now. All right? So then example 4, we turn the page on 312D. We go practice using that theorem and a little bit of proof writing. There's an interesting looking quadrilateral. It's looking like it's probably a trapezoid, but they don't give us indicators for that yet, so we can't assume that, but it looks like it might be. It's a big four-sided figure. There's a top left vertex labeled W. Got that backwards in my Braille, didn't I? There's a right angle indicator up there. How many degrees is that W point then? Or not point, excuse me, angle, 90 degrees. Over at the top right is X. And how many degrees is that? Oh, there's another right angle indicator. That's 90. Down at the bottom right, they have a little line indicator pointing into angle Y, vertex Y, and that is 50 degrees. And then back up to angle Z, up towards the top left, just below W. They've labeled that A degrees. So we can find that A degree angle by knowing that we've got 360 degrees on the interior of our quadrilateral. We're going to add up 90 and 50, subtract it from 360, and figure out A. So the next page shows the proof. Starts out with the measure of angle W plus the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 360 degrees. And the reason we can write that is Theorem 8-1. The sum of the measures of the angles of a quadrilateral is 360 degrees. Then the next line shows 90 plus 50 plus A equals 350. And the reason why we can do that is our substitution property. Then we combine the 90, 90, and 50 like terms, and we get 230 plus A equals 360. That's just adding, combining like terms, combining our constants. And the next line shows 230 minus 230 plus A equals 360 minus 230. And the reason we can do that is our subtraction property of equality, subtracting that 230 from both sides to undo it. And we're left with A equals 130. 360 minus 230 is 130. So therefore, the measure of angle Z is 130. So now they have a your turn down in print. They don't even give you a drawing. They just say a story problem. They say, find the missing measure if 3 of the 4 angle measures in quadrilateral ABCD are 50, 60, and 150. So this is some simple math. We don't even need to have a drawing. We just know, well, we've got to get this to add up to 360. So if we've got 50, 60, and 150, we're going to add those all up. 50 and 60 and 150, we get 260. 50 and 60 is 110, and 150 would be 260. Subtract that from 360, and our other angle needs to be 100. So we can all add up to 360 degrees. The next example, again, doesn't have a drawing, but it kind of does an algebra link. And it gets us to start thinking about substituting in measurements that might have variables in them, and then using our algebra tools to solve for that variable, and then plugging that information back in to get the measurements of our angles. So let's walk our way through this proof so that you can do this. This would be probably something you might see on an end of course exam because it pushes you a little bit further. It says find the measure, this is number 5, find the measure of angle U in quadrilateral KDUC if the measure of angle K is 2x, the measure of angle D is 40, the measure of angle U is 2x, and the measure of angle C is 40. So write it all out using your proofs. That's what they do. The measure of angle K plus the measure of angle D plus the measure of angle C, or U plus the measure of angle C equals 360. Why do we get to write that out? Because of theorem 8-1. The sum of the measures of angles of a quadrilateral is 360. Then 2x plus 40 plus 2x plus 40 equals 360. That's using our substitution property. Then we combine like terms. 2x and 2x is 4x, 40 and 40 is 80, so we simplify our equation to 4x plus 80 equals 360 by adding or combining like terms. Then the next step is to subtract 80 from both sides. 4x plus 80 minus 80 equals 360 minus 80. That's using our subtraction property of equality. And then we have 4x then equals 280, because we simplify it. 360 minus 80 is 280. And then the 4x plus 80 minus 80, we get rid of those 80s and just have 4x. Basic algebra. So 4x equals 280, we know we need to divide by 4 on both sides to undo the multiplication of 4 times x. So we're going to divide using our division property of equality. And we get x equals 70. Now that's not the answer. Careful, careful. They wanted to know the measurements of angle U. We could find the measurements of all the angles, but we'll go back and look at our question. It says find the measure of angle U, and it says measure of angle K is 2x, measure of angle D is 40, measure of angle U is 2x. Okay, well, we're going to plug in that 70, and the measure of angle 2 is 2 times 70, which is 140. You turn your brain on and think a little bit harder. You also know the measure of angle K. It's also 140. It's a 2x. And then C and D were given at 40 and 40, and you're going to learn later that this is a parallelogram. Opposite vertexes are congruent because we're going to pretend that diagonal is a transversal, and we're going to create alternate interior angles. That's coming up, but just to put it in your mind to think about. On the your turn on the next page, 313C, again, it gives you find the measure of angle B in the quadrilateral ABCD. If the measure of angle A is x, the measure of angle B is 2x, the measure of angle C is x minus 10, and the measure of angle D is 50. So we've got to do a little bit more work here. We're going to add up all of our angles, right, to equal 360, because we know by the sum of the measures of the angles of a quadrilateral have to be 360. So the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D have to equal 360 degrees. So we substitute in our values. A is x plus B is 2x plus the C angle is x minus 10 plus the D value is 50, and that all has to equal 360. So we clean up that left side. We combine all our like terms. So x, 2x, x, that's 4x. And then a minus 10 and a 50, that's a negative 10 and a 50, that becomes 40. So we should have 4x plus 40 equals 360. Now we're going to subtract 40 from both sides. And 4x equals 320. Divide by 40 using our division property of equality, and x equals 80. And they asked us what the measure of angle B was, and so we go back to our question, and B was 2x, so we have to plug in our x. 2 times 80 is 160, so you'd answer the measure of angle B is 160 degrees. So that's the end of lesson 8-1. You had a few vocabulary words: quadrilateral, four-sided figure; consecutive sides, consecutive angles; non-consecutive sides and non-consecutive angles; and also opposites. You could call them opposite sides or opposite angles when you deal with non-consecutives. And then the diagonal, which joins your non-consecutive angles or opposite angles together, and then creates those two triangles that allows us to prove that there are 360 degrees on the inside of our quadrilateral, the sum of the measures of the angles of the quadrilateral, the interior angles of the quadrilateral. All right? So that's the end of lesson 8-1. I would recommend for extra practice you at least do the check your understanding on page 313 and 314, number 1, or actually 2. That doesn't help you. I would start at 3 because number 1 and 2 want you to sketch things. Don't worry about that. I would start at number 3 and do 3 through 12, and that will give you really good practice at all the concepts in this section. And then be prepared in class that we might also do some extra exercises to make sure you practice the concepts in this section. All right, everyone, do good thinking. We'll see you in the next video.